chapter 10, 6, or 5, what we're doing here is just, we're basically doing the same thing. We put in formula, or in a story form, and so we've got to figure it out. And keep in mind, again, up above, you got to state the null and alternate hypothesis, state the decision rule, compute the value of the test statistic, what's your decision regarding that, and what is the p-value. Okay, so we've got all those that we need to answer for each question. So in A, B, C, D, E, again, five answers. A up here, I'm sorry. Okay, so for 5, and we'll read that, the manufacturer of the X15 still-belted radial truck tire claims that the mean mileage the tire can be driven is 60,000. So let's just get our data in there. The mean, right, of our population in this case is 60,000. Okay. Assume the mileage where follows the normal distribution and the standard deviation of the distribution is 5,000. Okay. Crosset Truck Company bought 48 tires, so my N is 48, and found that the mean mileage for its trucks is 59.5. So the mean of the sample, in this case then, mu is 59.5, and at the 0.05 significance level, then I have to, is Crosset's experience different from that claimed by the manufacturer at the 0.05 significance level? So first I have to state my hypothesis. Well, we're wondering if this 59.5 is equal to this. I can't see any place in there where I want to find out if it's greater than or less than or anything like that. So I really want to know if this 59.5 is substantially equal at the 95% significance, or at the 5% significance level. Okay, so it's our formula is the same and whatnot. Now I do got to state the hypothesis. So let's state that again. These are a little bit tough, and so if you want to do it kind of like this, and you go, H, and you want to go, maybe for my next letter I'll make it smaller, H sub 1, and H sub 0. I could do that. Okay, so my H sub 1, I could put colons in there too, right? Dang, I'm gonna start looking first class here. It's kind of scary. There we go. Okay, so my H sub 1 is just that mu is equal to 60,000, and H sub 0 is that mu is not equal to 60,000. And I did go to here, so I went to I put the mu is, and I wanted to find unequal, so I went to insert, I went to symbol. Up here, this drop down, it was easier for me to find it if I went to mathematical operations, and then you'll see, there's a pot full of them, so you got to find it, but there it is, right? So I put that in there, and got out of there, and away we went. So what did I do? I somehow got that copied or something. So so anyhow, you guys can do that to state it. So again, my significance level is this, and it's a two-tailed, right? And so I need to go find then this 0.5 minus this is, I'm sorry, 1 minus this then is 0.95, and half of that is 0.475, right? So I come and I take a look and come down my 0.475 somewhere's in here, right there. So 196 again. Imagine that. Okay, so we get pretty good at that. And it's two-tailed, so I want to know anything if it's outside of, or reject Z if it's outside of a minus 1.6 or outside of positive 1.96, right? So plug it in, right? I'm going to calculate a Z value, and I've broken it up a little bit. I did the top one right there. The bottom one, I got the standard deviation, which is 5,000 divided by the square root of 48, okay, and that ends up being this, okay, and then I've got to multiply those two. Oh, I don't multiply those two, do I? I divide the one from the other. Heck, I'm sorry. did I say 5,000? This is 500. So I got 500 divided by my 721. Okay, so I end up with a z of minus 0.69. Can I reject if it's outside of that? Well, it's not outside of that, is it? I mean, it's inside of that when I look at that. Okay, so it's 0.69. Okay, and my it's 1.96, isn't my, okay? And so if it's going to be in this dark blue, 1.96, it's going to be covered, and I'd go to 1.96 up there. Okay, so it's within that, and so because it's within that, I fail to reject. I can't reject it. Okay, but then I got to go and figure out at that z value then, okay, what my p-value is. Okay, and again, I look at, I got the 0.69282, so I got to go look at my chart, and your guys' again is in the back of the book, but 0.69, right? And I could probably interpolate a little bit if I wanted to, but this probably gets us pretty close. 0.2549, 0.69. Okay, so 0.2945. Yep, there we got that. Okay, but that's going to be just on one side. Okay, so I can go to the other side and I calculate that amount too, and thus it would be, for a two-tailed test, I got to take that times 2. So this is simply equal to, I'm sorry, it's this, which represents this part, right? 0.25 or 24, something like that, wasn't it? I don't remember what it is, 2459 or something. Somewhere's in that neighborhood. But I need to know then what this part is, and so I've got to take that and subtract it from 0.5. Oh, I think I'm doing that wrong again. Let me go back and revisit that. I got to go this way because I'm interested in finding then, and it's somewhere around here. What? I thought I hit that. Sorry. 0.24. Lanny's making funny faces at me. So somewhere's in that neighborhood. But I'm interested in finding out what this area is, right? And then this area over here as well, if I got a two-tiered test or a two-tailed test. So I've got to take this is equal to 2 times parentheses 0.5 minus this. Sorry, I got a little bit confused. There's a 49% probability of finding a more extreme value, and I might have said this wrong before. I think that means that there's that big of a percent to find a value that's outside of this. Outside of this range. This z value that I found, or the 59,500. Okay, so yeah. What do we say if we rejected we failed to reject it, meaning that the Crossett's experience, if I go back and look at the problem, Crossett's experience is not significantly different from what the tire company had outlined or had put in their advertisements. They might have to take that into court sometimes to prove or disprove those things. So there you go. Sorry for a little confusion on that one.